And just like that, we're back in the hole. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 27th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you'd like to leave a comment or question, please do so. We'd be happy to respond. And if you'd like to make a contribution to help support the cause, it'd be most welcome. Hit the super thanks button down below, the heart with a $ sign there. With that, I'd like to thank the folks that donated last week. Tim Caston, E. Slate, Evolution Moto, O. Dillard, and B. Nadine. These are all longtime contributors. We really appreciate your contributions. And with that, let's get to work. First up, let's take a look at significant wave heights around the planet, starting North Pacific. Pretty calm pattern, though. There is a tropical system, actually a typhoon, minimum typhoon, 70-knot winds southeast of Japan. Generating surf there, but nothing aimed at the U.S. West Coast or Hawaii for the moment. In the South Pacific, a little bit of a gale with 27-foot seas south of Patagonia, but otherwise no real obvious swell production going on. North Atlantic, calm pattern, as one would expect for this time of the year. South Atlantic, little gale with 20-foot seas, but not really doing a whole lot. Indian Ocean has the most activity, a gale here with 40-foot seas, pretty much aimed southeast, and other bits, associated bits of fetch in the 23 to 26-foot range. Probably not doing a whole lot. Also notice this right here up along the west coast of Australia. 20-plus foot seas, probably a pretty windy, stormy mess right there at the moment. But before we get into all that, let's just take a look at current conditions. We're going to look at the buoys, starting up in the Pacific Northwest, Grays Harbor buoy number 036 off the border there of Oregon and Washington. We're looking at all the energy hitting this buoy all the way up from 33.3 second period. There'll be super energetic swell. There is 0.0 feet of that. The whole way down to 5-second period, just pure wind chop. See a little bump here at 8.3 seconds, but it's only 0.7 of a foot. Another bump at 14.3 seconds at 0.8 of a foot. See what the algorithm says. Primary swell, 1.1 feet at 13.7 seconds from 217 degrees, making surf at about 1.5 foot. And then secondary swell, 0.7 feet at 17.3 seconds from 223 degrees, making surf at about 1.2 feet. So, all in all, pretty quiet there in the Pacific Northwest. Heading down to Northern California, the Point Reyes buoy just north of San Francisco, number 029. This is a seated buoy. And by the way, if you've not looked at the Stormsurf current North Pacific overview forecast, there's a link right at the top of that page. In fact, I could probably show you here. Let's see if we can just get down the Pacific forecast right there. Click that. You'll get to the link. There is discussion about significantly cutting the seated buoy funding. All these buoys we're looking at here are seated buoys. If the funding gets cut, supposedly a bunch of the buoys are going to disappear. Probably something we as surfers and ocean people want nothing to do with. The more buoys, the more accurate they are, the better for our livelihoods and for our safety. All right. So, onward, Point Reyes buoy, just north of Ocean Beach, San Francisco. Same sort of profile, little bump of energy there at 18.2 seconds, another one at 13 seconds, and then some nondescript generic wind swell in the mix there. Primary swell, 1.2 feet at 13.3 seconds from 193 degrees, producing surf at 1.6 feet, and then secondary swell, 0.9 feet at 17.6 seconds from 201 degrees, also making surf at about 1.5 feet. And looking today, that's what it was, knee-high, something like that. Down to Southern California, the Point Loma South buoy, 191 there off of San Diego. Same sort of profile, a little bit of 18-second energy, a little bit of 13, a little bit of wind swell in the mix. Primary swell, 0.7 feet at 17.3 seconds from 214 degrees, surf a whopping 1.2 feet, and the secondary swell 0.9 feet at 13 seconds from 190 degrees, also producing surf at 1.2 feet. So pretty calm sea state all up and down the U.S. West Coast. Then finally over to Hawaii, the Lanai buoy there on the south shore, buoy number 239. Kind of the same sort of pattern, a little bit of energy here in the 14-second period range, a little bit of wind swell mixed in. Primary swell 1.6 at 1.6 feet at 9.2 seconds from 169 degrees, making surf at 1.5 feet, and then 1.1 feet at 12.6 seconds from 175 degrees, making surf at 1.4 feet. So again, a very calm sea state across the board. Let's review what's been going on over this in the southern hemi, the South Pacific, for the past week. We're going back to last week's video, or when it was made, 18Z on Sunday, the 20th of July. We'll just put this into motion. There was a little gale that developed right here on Wednesday. That'd be midweek, the 23rd of July, with 27.4 foot. Oh, no. Yep, that's it. 27.4 foot seas. Here's the coordinates: 49.85 south, 159.5 west. See it right there. Aimed well to the north. That gale lifted north. Seas built to 29 feet for a nanosecond there, dropping back down to 27 feet, and then fading from there on Thursday. That is the first of two swells, maybe even three, that are heading north, really targeting Hawaii very well. Hawaii's been, for the most part, pretty starved for surf this entire summer, so this is at least a nice little pulse aimed directly at them. A stronger system built right behind, starting on Thursday with 33-foot seas, building again 33 feet up to 34 feet, 35 feet, and then peaking out at 37.2 feet on Friday, the 25th of July, so 2 days ago. And again, on that very northerly path, swells fading from 36 feet to 33 to 31 feet. And then, let's see, we're into Saturday, and still some energy continued into like Saturday night with 25-foot seas. And then that was pretty much the end of it. Here we are, current time right there. You see nothing happening of any interest. So two swells on their way north, targeting primarily Hawaii. Then let's review what happened over the North Pacific over the past week. We're already into Tuesday, Wednesday. There was some sort of a tropical system. That's really the only activity right about in there that started developing. What was that, about 600 or 700 miles southeast of Japan on Saturday into Sunday. Here's current time. Seas in the 40-foot range per the model. That's probably a bit overstated. This is only a bare minimal hurricane. My guess is the seas are probably more in the 32-foot range, though the GFS model tends to overhype it a little bit. We'll see what happens with this over the next week when we get into the forecast section of the presentation, though there was some hype around this system about 2 or 3 days ago. We'll see if that still holds. Looking back over the past week in the North Atlantic, still, there we go, another gale. What do we get? Seas pushing 17 feet, pushing off the northeast U.S. coast, lifting up towards Greenland. Seas still in the 18-foot range. That was on Wednesday, maybe even almost 19 feet into late Thursday and Friday. Swell from that already hitting Ireland and Scotland area. Where are we? That's Saturday. We're going to keep going out. We have a little bit more. There we go. So believe it or not, we're into the end of July, and it seems as if a springtime pattern is still in control of the North Atlantic. And if you're anywhere on, at least in the San Francisco area, it still feels like spring as well. Pretty cold, kind of damp, kind of miserable. In the South Atlantic a week ago, the 20th of July, yes, there was a gale with 38-foot seas pushing off to the east. It faded. You can see the swell front from it that was pushing towards Africa into, looks like it hit there about Thursday or Friday. Another little gale developed, only 20-foot seas behind that. See where we're at. And then as of today, you see some sort of gale activity developing, pushing well to the north with 24, maybe even 25-foot seas, targeting this portion of South Africa. So perhaps, let's see, we've got one more frame there. So perhaps some swell is on the way for exposed breaks in, I'll call it Southeast South Africa. And then our final stop, the Indian Ocean, a week ago, gale with 30-foot seas southeast of South Africa. That faded out pretty quick. Stronger gale developed with 43-foot seas, but you can see the arrows here. All the energy really aimed at Antarctica and Antarctic ice, with the gale itself pushing inland over Antarctic ice. A little bit of a gale here with 20-some foot seas pushed up along the coast of Western Australia on Wednesday. Continue rolling out. Another similar sort of gale started setting up on Saturday, poised to impact the coast on Sunday, and we saw from a previous image that is in fact happening as we speak, with another gale with 34-foot seas in the deep South Indian Ocean, and looks like it's mainly, again, a penguin storm targeting Antarctica. So what does the forecast have for us? And we're going to focus on the South Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north, and we actually have it right here. That is, here's the northern branch of the jet. Here's the southern branch of the jet. You see it pushing north, trying to consolidate with the northern branch. What you end up here is a clockwise circulation just east of this northward push, somewhere either in between here or here. Clockwise circulation in the upper levels of the atmosphere can also manifest itself down at the lower levels of the atmosphere. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. As winds get traction on the ocean surface, generate seas. As those seas radiate away from the fetch area, the lesser period elements decay off, exposing longer period groundswell. And as that groundswell radiates into places like Hawaii and California, that generates surf. But it all starts with a trough in the upper atmosphere. So we have that, and this is providing good support for gale formation. We'll put this into motion. You see the trough continues into Monday and Tuesday right in this area. Now, conversely, west of there and southeast of New Zealand, you see a ridge. The jet pushing far south, it splits, and that is where you would get high pressure. So high pressure there, low pressure there. That actually would help create a gradient and tighten up the isobars and maybe make yet more fetch aimed off to the north. This is for Monday night, the 28th of July into Tuesday. Then you see the trough gets pretty pinched. A split jet stream flow takes over. No clear support for gale development. Then you get into like Thursday and Friday. There's almost a little trough trying to organize here, but not so much. Maybe another one here somewhere south of New Zealand into Friday. And there you go. There is a better trough. Now, the issue here is the ice line. The ice line probably somewhere around 63 south. We'll have to look when we go look at the wave models. But there's probably a little window, and that's good. You know, when you get 140 knot winds lifting off to the northeast, that would provide pretty decent support for gale development. You see it actually sweep the whole way across the South Pacific into a week from now. It'd be like Sunday night or so, the 3rd of August. And the jet, after that, pretty split. The southern branch, pretty far to the south. Probably not providing great support for gale development. So let's go take a look down at the ocean surface. This is surface level pressure, surface level winds. We know we have a trough here, and sure enough, we have 35 to 40 knot winds trying to get organized southeast of New Zealand. Ice line, again, somewhere right around in here. We have spurious bits of other gale activity, but winds not significant. Now, here we go as we get into Monday. See this fetch building, again, lifting hard north. 35 to 40 knot winds. Really 45 is what we want to get, like a 17-second period swell. But, you know, you kind of take what you can get. Here we go, 40 knot winds into midday Monday, lifting north. That looks like it will provide good support for gale development into maybe Tuesday morning or so. Behind that, you see we have fetch all aimed hard south at Antarctica. That will do nothing for us. Another bit of fetch here starts developing on Thursday north of the ice line, 45 knot winds there, but even more so. Let's go back just a little bit here. Okay, so Wednesday evening, that is 60 to 65 knot winds. That is a storm over a pretty good area aimed off to the east, and that is in the swell window for California for sure. I think it's cut off for Hawaii, though. Whatever can work its way through to the Tasman Sea would impact Hawaii, but probably more so Fiji. Put this into motion. You're into Thursday, the gale still holding with 55 knot winds, actually a storm again, I'm sorry, and in the swell window, but as it starts to enter into the greater southwest Pacific, you see winds dropping off pretty quick, 45 knots, 40 knots, and shrinking from there. So there is potential, it looks like midweek off in this area. We'll go out further. We're into Saturday. You see a lot of fetch aimed due south there. Another little gale here. Let's see if we can put this back into motion. Somewhere around here, this Saturday. So this is almost a week out. Saturday, the 2nd of August. Fetch with 35 to 40 knot winds aimed off to the north again. Yeah, it's almost like a backdoor swell producer for Fiji and certainly into Hawaii. And winds, oh, this is stronger than what earlier models of the showed, like even this morning when I was building forecasts. It's 45 knot winds aimed off to the north. Pretty good pattern indeed, though it is a week out from actually occurring and aimed back at New Zealand. Also, look at this gale forecast here. I mean, Fiji just in the bullseye for all kinds of activity if the model actually plays out. Again, it's quite a ways out. The model has been grossly overhyping things more than about 4 days out. I don't believe any of it, but it's something to consider. What is the effect of those winds on the ocean surface? Here we are, forecast model, current conditions, pretty slack pattern, but here comes our next scale trying to build. We're into Monday, the 28th of July, 23-foot seas, building to 24 to 26 feet, and holding right at about 26 feet, aimed off to the north and aimed well at Hawaii. Hawaii about 158, 155, somewhere in here. So reasonable swell there, but also seems that swell could also be wrapping towards California. None of this particularly huge because the seas aren't that high. I mean, for California, you really want to see 30-plus foot seas. We're not seeing that, but at this point, you take whatever you can get. We're also now watching on Wednesday, the 30th of July, the scale south of Australia. It blows up theoretically pretty quick with seas building to 48 feet to 52 feet here, certainly on the Great Circle Path. That would be a long period swell over a week out. And again, this is still 3 days from even forming, but something to watch. We actually had one of these over in the Indian Ocean with 54-foot seas, and measurable swell did hit the buoys. But I think I'd like to see something more than measurable. I want to see something rideable. This, given that its close proximity, probably would produce rideable surf and with a pretty good long period on it as well. Pushing south of New Zealand on Thursday with seas fading from 47 feet to 44 feet to 41 feet, and then finally fading, but free and clear in the southwest Pacific. Now there's another system, here we go, somewhere in here on Saturday, theoretically developing 28-foot seas, there's a broader area of 28-foot seas. This is new here, 34-foot seas, again, Fiji off here, Hawaii up over this direction, off, this is 10 north, so it's north of even the end of the chart here. You get the general idea, though, but we're almost a week out. I give this very little credence at this early date. All right, let's take a tour around the rest of the planet, starting in the North Pacific. Here is our typhoon south-southeast of Japan. It's forecast lifting. Now see this, it kind of dissipates, tries to reorganize. I haven't seen the latest run of the model, what it does. it pushes off, just sort of meanders here off Japan. We're going to go back and look at some other features on this in a minute. And you see what it's doing. It actually is pushing towards Hawaii. It was much stronger on earlier runs of the model, like 3 days ago, and actually promoted the idea that there was going to be some significant west swell pushing into Hawaii. Now you see, as we're getting into reality, that's not happening. We'll put this into motion again. Notice some tropical systems, one here southeast of the Big Island. We're on Tuesday, tracking pretty much due east of and well south of the Hawaiian Islands. Probably no swell from that. Another system 84 hours out, theoretically developing south of Cabo. Not very strong, lifting off to the northwest. That is actually looking much weaker than even the run of the model 6 hours ago. So the odds of that one or that one even forming and doing anything are probably pretty low. And I'm not even looking at that, but it's something you go look at the models every day, go, oh, let's see what it's going to do, right? So you can follow along and make your own decisions about what's going to happen here. The North Atlantic, next up, we'll put this into motion. One would not expect to see anything at all over the next week. But you see this kind of offshore fetch for Portugal. Kind of weird, kind of strange. And then is this more low pressure trying to get organized off the U.S. West Coast? Actually, it's fetch pushing into the Cape Hatteras area and the mid-Atlantic. So perhaps some surf there. The U.S. East Coast has been just utterly starved for surf this entire summer. So any nudge in the right direction is a gift worth taking. To the South Atlantic, over the next week, here we go, a gale with 25-foot seas over a broad area targeting South Africa, Southwest Africa initially. Sea sort of falls southeast there, 28-foot seas. Also, building too. Let's go back and look at that. 30, right about there, 32.5 or 6-foot seas, something like it, 32.8. So swell from South Africa from that. Notice this other system here along Argentina area. Fetch continues, pushing South Africa, plenty of swell. Oh, and it moving close to the coast on late Thursday into Friday, the 1st of August. That is 25-foot seas, nuzzled right up to the coast and then sweeping into the Indian Ocean. We're 132 hours out. Another gale, 30-plus foot seas. Not huge, but pushing, targeting South Africa again. Oops, and that was the last frame. And yet more behind that. So the South Atlantic looks to be being fairly productive. And last but not least, the Indian Ocean with its gale with 38-foot seas. Let's see what that's going to do. Crashes right into Antarctica. Another gale behind that with 33-foot seas. Certainly making sideband swell up into Australia. Another one even behind that. We're only on Tuesday, the 29th of July. What was that? Let's go right about there. That looks like about 38-foot seas targeting Bali and Indonesia well, and then fading out, but not completely gone. Another system. Now here you go, pushing well to the northeast with 40-foot seas. Oops, building to 42-foot seas. Do we get higher than that? No, we don't. Targeting Western Australia, Bali, Indonesia. That certainly would be a swell producer. And yet another system. We're out a week now, Sunday the 3rd of August, with we call it 35-foot seas, pushing south of Australia and certainly generating swell. I'm going to go back through this one more time. I want to go look at the gale. There it is. This gale here. Now this, yeah, certainly for Tasmania and southeast Australia, somewhere in this area, could produce swell for that. But again, there's the bullseye, the 52-foot seas, all aimed off to the east, pushing in towards the southwest Pacific. So we know there's two swells in the water, targeting primarily Hawaii, and a third trying to organize in the next 2 days, targeting somewhere between Hawaii and the U.S. West Coast. Let's take a look at local wind conditions. It appears for the moment that the incessant trade winds that have been sweeping down the North and Central California coast for the moment have dissipated with a relatively weak wind state and sea state along there. Trades for the Hawaiian Islands, light too at only 10 knots. So we get into Monday, we get the sense that maybe high pressure is trying to build in, but we still have low pressure in the Gulf of Alaska in July, and not early July, late July, and then two possible tropical systems here further to the south. Winds 10 to 50 knots along the north and central California coast. Trades light 10 knots for the Hawaiian Islands. Tuesday, trades build a little bit, 15 knots pushing down north and central California coast. Trades still about 10 knots for the Hawaiian Islands. You see the tropical systems passing south there. All the fetch for these aimed off to the east. Yeah, east-facing shores of the Big Island, maybe not even Maui. I would say just the Big Island. Potentials for some surf there. Get into Thursday, northwest winds. Says 15 to 20 knots, but I mean, if you go look at the local wind models, it's maybe only 10 knots real near shore of the coast, though probably junked up from these outer winds. Trades build 15 knots for the Hawaiian Islands, mainly as the tropical systems pass off to the west. As we get into Friday, northwest winds still 15 knots for most of California coast. Trades 15 knots for the Hawaiian Islands. Next tropical system forms, organized, lifts north. Doesn't look anything particularly impressive by Saturday. It's all but gone. Trades 15 knots for the Hawaiian Islands. Local pressure gradient, here we go, starts building again for California. 15 to 20 knots along the coast. We can get into Sunday here and pretty much a repeat of that same pattern. The sense is pressure is generally higher in the Pacific Ocean for this time of year than what we're used to. That's what's generating all this like spring-like northwest winds. California, at least the San Francisco Bay Area, is in record cool temperatures just from the prevalence of fog and not a lot of sunshine, and the onshore flow pushing the fog well inland, keeping temperatures pretty well below normal. It is winter in summer in at least the San Francisco Bay Area. The backpackers or hikers temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road in Yosemite, where they cross the elevation. Here's elevations, temperatures at different elevations, 8,700 feet right there. Temperatures cool there too, quite comfortable from a hiking perspective in the 50 to 55 degree range. And I looked, there's some temperature gauges up there too, highs like 60 degrees for a couple of hours in the afternoon. That pattern just basically looks like it continues, maybe warming some as we get into the week, but still 50 to 55 degrees, maybe barely getting to 65 degrees if you're lucky. And then as we get into about a week from now, that would be the 3rd of August, temperatures warm up a little bit, probably more seasonal in the 70 degree range, 60 to 70 degrees. So, but still, from a hiking perspective, not blazing hot, not super dry, probably not good, not as dangerous for fire problems in the Sierra as well. And that's something we can all be thankful for. So what's all this mean from a surf perspective? We'll go up starting at the Columbia River area there, the border between Oregon and Washington. Surf heights, you see it, 1.5 foot if you're lucky. No meaningful swell. They're really shattered from any southern hemi swell for the most part. Swell heights 1.2 feet at 7 seconds kind of thing, maybe 2 feet at 7 seconds. So no meaningful swell forecast for the next week for that area. Down to Northern California, Ocean Beach, San Francisco, surf heights 1.8 feet dropping to 1.1 feet. That's probably more of an anomaly there. And then building into the 2 foot range, you see the northwest winds. This is not right on the coast. This is a bit off the coast in the 15 knot range for the most part. Swell heights, not really anything going on until you get out to about Thursday evening, 1 foot at 16 seconds. This is the sideband energy from that first little gale, called a primer gale, that's forecast pushing into Hawaii. And then a little bit more meaningful swell as you get out into Sunday, maybe 1.2 feet at 16 to 17 seconds and building from there. Down to Southern California, Dana Point, surf heights like completely off the charts until you get into about Thursday, Friday when that first small swell hits. 1.5 feet building up into the maybe 2 to 3 foot range. Winds really light. Swell, just non-existent until you get 1 foot at 16 seconds, 1.2 feet at 13 seconds, and then building. Now, this is kind of a mixed bag here. 2.5 feet. I think this is actually tropical swell, 2.8 feet at 13 seconds sort of thing from 175 degrees. But there's going to be longer period and more, maybe a little bit more meaningful swell underneath that. Then to the South Shore. Well, this is a good South Shore of Maui, but we're using this for Oahu as well. Not a whole lot happening, but you see surf heights starting to come up as we get into Wednesday, Thursday, Friday, then backing down some. Trades, pretty much light, not bad at all. Let's see if we can pick out some swell here. 1.6 feet at 17 seconds, building to 1 foot at 16 seconds on Tuesday, up to somewhere around 1.5 feet at 14 seconds. And then the bigger swell starts pulling in 2 feet at 17 seconds, 2.3 feet at 16 seconds, 2.5 feet at 14 seconds. That theoretically should make surf in about the 3.5 to 4 foot Hawaiian range for exposed south-facing shores, and then dropping off from there. Off to South Africa, Jeffreys Bay. Surf heights, it looks like it's flat, but it's still, 6-7 feet. That's probably a little bit overstated because where this anchor point is located is just a little bit off the coast, maybe 10 miles off the coast. But you get the idea. Then a big blow of wind with 35-knot winds on Thursday. Surf height comes up. That's that local gale along the coast there. 27-foot surf dropping down from there. Pretty windy pattern. Look at it going from offshore to onshore at some point. Let's go look at swell heights. 9 feet at 10 seconds. A little pulse here on Tuesday at 5.5 feet at 13 seconds. That drops off. And then we head up 18 feet at 14.5 seconds. 15.8 feet at 15 seconds. You get the idea, but this is probably a pretty stormy, confused sea state. And our final stop on the tour, Bali, Indonesia, that area. Surf heights 10 feet today, fading into the 6 foot range sort of thing on Tuesday. And then coming up, next swell hits, surf heights 14 feet. That's probably a little bit overstated, you get the idea. That'd be on Wednesday, dropping down on Thursday. Then as you get later into next weekend and the early part of a week out from now, surf heights heading up again into the 13-foot range. Swell heights, let's see what we got. 8 feet at 13 seconds, 4 feet at 13 seconds. We get into Tuesday, kind of bounces around, then back up to nearly 10 feet at 14 seconds on Wednesday, dropping down on Thursday, and then more just fun rideable surf, 4.5 feet at 14 to 15 seconds for the weekend, building to 7.8 feet at 17 seconds at the end. So just a steady string of swells. Now let's go take a look at the long-term outlook. We're going to examine the details around the two major weather oscillations that affect surf, rain, and weather in general over the long term. First up, the MJO, the Madden-Julian Oscillation, and then ENSO, the El Nino Southern Oscillation. We're going to start first with the MJO, the Madden-Julian Oscillation. There are two phases, the active phase and the inactive phase. The active phase is our friend. It is a low pressure system. The inactive phase, a high pressure system. The two phases of the MJO rotated around the planet from west to east on the equator. The active phase on one side of the planet, inactive phase on the other. They rotate around like that, polar opposites around the planet. The active phase, being a low pressure system, when it pushes south of your location, it takes warm, moist air from down at the ocean surface, lifts it aloft up into the atmosphere. That moist air then feeds energy into the jet stream, making the jet stream stronger. And downwind of that location, the jet helps dig out troughs. It takes a more energetic jet to dig out the troughs, and the troughs, of course, help support the formation of gales and low pressure system, which in turn generates surf. Inactive phase does the exact opposite. It's a high pressure system, creates falling air, cuts the energy off from the jet stream. The jet stream gets weak and splits and does not support troughs. All right, so the other thing is the inactive phase of the MJO increases trades. Trades are generated by high pressure in the equatorial regions of our planet. The inactive phase, because it is a high pressure system, well, it marries up and it basically strengthens the pre-existing high pressure systems over the oceans, building stronger trades. The inactive phase, because it's a low pressure system, cuts out some of the energy from the prevailing high pressure systems and then weakens trade winds. So we can look at this. This is data from the TAO buoy array, a series of buoys strung across the equator, East Pacific here, West Pacific here. That's New Guinea right there. There's the equator. International date line right here. The buoys have wind sensors on them, and those wind sensors can be used to sort of get at least a rough idea what the trade winds are doing. So you can see here in the East Pacific, just looking at the arrows, trade's pretty strong out of the east. In fact, very strong out of the east. Same thing over the Central Pacific, then a bit weaker in the West Pacific. But it is not the actual wind speed, it is the anomaly, difference from normal for this time of year. Trades this time of year are normally pretty strong. But even with that, looking at the arrows, you can see, no, these easterly winds are stronger than even normal. So these are probably a sign of the inactive phase of the MJO, at least. Again, the inactive phase of the MJO being a high-pressure system, it marries up with prevailing high-pressure systems in the oceans and builds stronger than normal trades. We also see something similar to that going on in the Central Pacific. Now, trades, they're still stronger than normal in the West Pacific, but not nearly as much. Let's go look at the forecast for the next 2 weeks. And this is where really the title of the video came from. We're down in a hole. 850 millibar zonal wind anomalies. These are winds of about 4,700 feet, but a pretty good proxy for what's going on at the ocean surface. This is the whole planet right here. We'll slide it up a little bit. There you go. The date line, 180 west right there. So, and the far West Pacific starts 125 west, so right there. Past performance here. The blues, easterly anomalies, stronger than normal trades, the inactive phase of the MJO. The reds, stronger than normal westerly anomalies, or otherwise weaker trades. Stronger trades here, weaker trades here, but this is all over the maritime continent. So you see we had this pattern of westerly anomalies right along here, building into the West Pacific until about 3 or 4 days ago. And then all of a sudden, even last week when we were building the video, we talked about this pattern of westerly anomalies that were forecast to build over the Pacific and fill the entire West Pacific. Well, we started to see those of you that are pretty eagle-eyed and mentioned it in the comments from last week's video. It looks like something's going on that's not as favorable as what we had hoped for. Well, like 2 days after the video, the GFS model just completely collapsed, started issuing forecasts of nothing but easterly anomalies filling the West Pacific, and now here is where we are, with westerly anomalies confined to the maritime continent at best, and for at least the next 2 weeks, nothing but easterly anomalies, inactive phase of the MJO taking over. And you go, well, wait a minute, there is the Jetstream looks pretty good. Things are okay for the moment. I say, yes, that is true, because we've had westerly anomalies in control till about, even just 2 days ago. But at some point, it takes a bit for the ocean to respond, but my guess is at some point, this easterly anomaly pattern is really going to just start tearing the jet stream apart in the South Pacific Ocean. Outgoing long-wave radiation forecast for the entire planet. The blues would be more clouds than normal, the oranges and reds, less clouds than normal. How does that match up with the MJO? Active phase of the MJO, because it has warm, moist air rising, makes more clouds. That would be these blue shades. The orange and red would be falling air, high pressure, dry air, the inactive phase of the MJO. So last week we looked at this, and I think it was solid active phase blues the whole way through the end of the chart, and then 4 days ago that started getting softer and softer. Now here's the last little remnants of what was supposed to be a pretty thriving active phase of the MJO. 5 days from now it's gone. And let's get ourselves oriented. South America, Central America, Australia, New Guinea, the equator right there, date line running right down the middle. So you see inactive phase of the MJO, high pressure moving into the West Pacific. That'd be 10 days from now. 15 days from now, the inactive phase of the MJO in control. This is from a statistic model. This is the dynamic model. Thankfully, the dynamic model is not showing as strong an inactive phase as the statistic model 2 weeks out. You can see the difference here. But still, it's not showing any real flavor of an active phase of the MJO and no real good support for storm development over the next 2 weeks. Phase diagrams for the same two models, statistic model here, dynamic model here. How do you read this chart? Well, the active phase of the MJO moves from east to west around the planet on the equator, from the Indian Ocean to the Maritime Continent, to the West Pacific to the East Pacific, under the United States, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, and the farther that dot is away from the circle, the stronger it is. So you really want to see the active phase of the MJO somewhere like over in here and up, like phase 6 is what they call it, and up pretty far away from the circle. That would be like a monster strong active phase of the MJO. Instead, we have a weak to, I'll just call it a weak to at best modest active phase of the MJO in the Central Pacific, quickly forecast moving somewhere into some version of the Indian Ocean, and incredibly weak 2 weeks from now. That per the statistic model. The dynamic model suggests some flavor of the same thing with the inactive phase 2 weeks from now in the Indian Ocean and extremely weak. Then we go to the CFS model. This goes out 1 month. Past performance up here, forecast here. Dateline runs right up the middle here. Far West Pacific starts about 125 east, so right there. You can see plain as day here. The reds are westerly anomalies. That's what we want, active phase of the MJO. They were steadily increasing their coverage and their depth into the West Pacific until about a day ago. And now look at the forecast, just easterly anomalies in control. There is an active phase of the MJO pushing south of California, and that's probably what's contributing to the slew of tropical storms forecast south of Hawaii and off of Cabo. The active phase, oh yeah, the solid black contour here. The active phase of the MJO, because it's a low pressure system, that's what feeds tropical storm development. But you see easterly anomalies are forecast. If anything, a building weak inactive phase is already present over the Maritime Continent, and you just get the sense it's going to start traversing its way into and across the West Pacific over the next 1 to 4 weeks. So this goes out a month, with basically nothing but easterly anomalies in control. This is the hole that we are falling into. And then the CFS model going out 3 months. Past performance down here, the forecast here. Not as horrible looking on this chart as what we saw, but not as good as what it was supposed to be. In fact, this chart, well, again, here's the date line right up here. The far West Pacific starts 125 east. This is what has been happening. You see the yellows, westerly anomalies steadily building, and that is forecast to continue, but you start seeing these pockets of easterly anomalies building that weren't in the forecast last week or even maybe 4 days ago. That's starting to show up. You still see westerly anomalies. The model's hanging on to the hope that westerly anomalies will build about halfway across the Kelvin wave generation area, starting somewhere by the end of August. That's going out 4+ weeks from now. I don't know. That maybe is a bit of wishful thinking. We'll see. I was optimistic, holding on to hope. I don't know that I am anymore. All right. Here is the MJO overlaid. 2 contours, active phase of the MJO right now. That's driving some of this, the supposed westerly anomaly production that the GFS model saying it does, whatever it is, it's going to be gone in the next couple of days. Then you see the inactive phase of the MJO with neutral to easterly anomalies taking over into about the end of August. Then supposedly, here we go, 1, 2, 3, a 3 contour active phase of the MJO sets up, just completely takes over, and I'm not buying it anymore. Not buying it. This model has been saying continuously some major active phase of the MJO is just lingering about a month out. It's playing that same game again. It just doesn't make sense. Let's overlay the low pass filter. Now here's what is interesting. There is a little bit of hope here. This black line here, that's low pressure bias, the El Nino signal, if you will. It was centered last in March over the maritime continent. Here's the leading edge of it. You can see since about June, it's been steadily working itself east to a point right now that I'd put it at 145 east. And it's supposed to build a little bit more as we get into August and then basically be filling half the Kelvin wave generation area with a second contour setting up as we get into September. If nothing else, if this actually happened, that would be good news because you see where the leading edge of the low pressure bias was back in March, and it was even further back than that last winter. This is actually making good headway into the West Pacific. Not great, but decent. But you also see the high pressure bias. So here it is, 1, 2, 3. I think we actually had 4 contours at one point. This would be a full-on La Nina. It ended up being a Modoki La Nina, right? You see it collapsing as of right now, likely because of this active phase of the MJO. But then it sort of comes back and sets up the dividing line between the high pressure bias and the low pressure bias right at about 150 west. So halfway to the date line, roughly. That would not be bad if that happens. And so I'll give everyone a little bit of hope with that. But again, this model seems like it's biased a little bit more in favor of this low pressure bias than I think what is really happening. This is probably a better view of what is actually happened. Rather than looking at models, what is happening subsurface wise in the ocean? It is the ocean and it is the originator of El Nino and La Nina. It eventually gets coupled with the atmosphere above it, and then the two of them work together, but the ocean sort of has a mind of its own. This is data from the TAO buoy array again, East Pacific here, West Pacific here. These are the anchor lines on those buoys that are strung across the equator. The X's are sensors on the anchor lines. Use that and a model to fill in the gaps, and you get a profile of what the warm and the cold water is doing in the ocean. Why does that matter? Well, if you have stronger than normal trades, warm water gets more sequestered in the West Pacific. You have weaker than normal trades, the warm water starts sloshing off to the east. So last week, we'll start here. The 29-degree isotherm. This is 29 degrees centigrade, quite warm water. It was at 180 last week, maybe even a little bit east of there. It's regressing backward to the west. The 28-degree isotherm was like at 162. It's back at 165. The 24-degree isotherm 2 weeks ago was pushing about 15 meters deep into Ecuador, is now not even reaching there, and is coming to the surface somewhere about 102 degrees west. So this all suggests trades are building stronger than normal, starting to take warm water, push it off to the west. It is not the actual water temperatures that matter, though. It is the anomalies. And the picture's even worse here. Okay, we have warmer than normal anomalies in the West Pacific and in the East Pacific. 2 weeks ago, this was 1 to 2 degrees below normal and pretty much a nothing burger. Now all of a sudden it's 2, 3, 4, 5, approaching 6 degrees below normal. And there's a hard sensor right there and there picking up on this. So it's not all completely modeled nonsense. And you see there is a break now. The entire upper thermocline was full of warmer than normal water, and there is a stack of temperature sensors right in the middle of it. They're saying, no, temperatures are below, just slightly below normal, but you see also building here. So there's this sense that there's this pathway of cold water getting to upwell to the surface and just pretty much wipe out whatever progress we've made over the entirety of this summer. Let's go look at some other data. Here's Pentad data that's updated every 5 days. It uses the same sensors, but also has satellite data mixed in. It's still holding out hope here. and showing a little thin stream of warm water that was almost a Kelvin wave trying to make its way across the Pacific. But this is from the 22nd of July. Today's the 27th. This will probably be updated tomorrow morning, and my guess is that will be completely gone. Now it's only showing 1, 2, 3, so that'd be 1, 2 to 3 degree below normal water temperatures here, but my guess that's probably understated as well. So I'm putting less hope in this and more in the previous image we just showed. Here's sea level anomaly data in centimeters, the height of the ocean, and we only care about right on the equator, which is right there. There's the date line. That is New Guinea right there, Australia, Chile, Peru, Ecuador, Central America. It's only 5 degrees north and south of the equator that matter. You see that what this infers is, so it's a satellite, beams radar down on the ocean surface. They strip out the waves, the wind waves, the tide. Is the sphere of the ocean higher or lower than normal? If the sphere of the ocean is lower than normal, well, that infers that you have cold water at depth, and cold water at depth kind of contracts, and that'll carve out a divot on the ocean surface. Also, if you have stronger than normal easterly anomalies, it'll take the water there, dig it out a little bit, and displace it off to the east. Likewise, warmer than normal water at depth expands, create a bump on the ocean surface, and trades typically would be lighter than normal, so you get warm water expanding. So this shows clearly that cool pool. There's been these two pockets here, north and south of the equator, but now they're joined. It just all basically saying some flavor of it looks like La Nina is trying to develop now. And the official El Nino monitoring region goes from 120 west, so from here on the equator, to 170 west, so right in there, 5 degrees north and south of the equator. This is sitting right smack in the middle of it. Not a good thing. Upper ocean heat anomalies for the past year, West Pacific here, East Pacific here. Here is our La Nina signal, Modoki La Nina from last winter. All the cold water we hit like somewhere in late March, early April, and boom, the cold water disappeared. We got a flood of warm water discharging as it was building in the West Pacific, surged across the equator, and then starting about the middle of July, you just see it. The warm water all of a sudden just started fading, and here is our developing cool pool right smack in the middle of the Nino 3.4 official El Nino monitoring region. Subsurface is the precursor. The surface temperature is what really matters. Again, 5 degrees north and south of the equator, South America, Central America, Australia, New Guinea there, the equator right there, Galapagos there. You see the official El Nino monitoring region from 120 west out to 170 west, 5 degrees north and south of the equator. You see a developing cool pool filling that entire area. Yeah, warm water off to the east, warm water to the west. Everything that happens outside of 5 degrees north and south, we're not even looking at that. You see clearly a cool pool developing. You also see the mirror image of it in the Atlantic as well, that likely suppressing tropical storm development as low pressures push off the Sahel region in Africa over the Cape Verde Islands. Plenty of warm water, though, east of there. We'll see whether the Atlantic wakes up as we get a little bit further into the season. As this La Nina, assuming that's what it is, develops, then what that should actually do is help support hurricane development in the Atlantic Ocean. But if this is just building now, it's going to take 2 to 3 months before that starts manifesting itself in the atmosphere around the planet. The atmosphere is a big boat. It takes a long time to turn. So I don't know that this is going to have that much of a major impact on the Atlantic hurricane season. Certainly, it will impact the Pacific hurricane season, though. Increased trades just do nothing, creates shear, and just cuts the top off any hurricanes, at least in this region. Over here, maybe a better story, but we'll just have to see. Sea surface temperature trend for the Pacific, well, for the whole planet. Blues, cooling waters, oranges and reds, warming waters. Ecuador right there, New Guinea there, that's the equator, dateline out here. You see it clear as day. Cooling temperatures, quickly cooling over the main part of the Nino 3.4 area right in there. So not looking so good. But also notice you do have warming temperatures here, at least along the California coast, because the northwest winds have backed off. But we'll see whether that holds. The alternate sea surface temperature anomaly chart. Let's see if we can get the title. There you go. See it right there. Which many of us have been dismissing as being overly cool, and I still say it is, but it's been, you just see that triangle right there. For months, it's been saying, no, water temperatures are already cooler than normal, and they still are. You can see it building here. This looks like a clear La Nina pattern, and maybe this is the more accurate depiction of what's actually going on, at least in the Equatorial Pacific. The 15-day sea surface temperature anomaly change doesn't show the cold pool as marked as the other one does because it goes out 2 weeks. The other one only goes out a week. This change really only has happened pretty much since last week's video, but my guess is by next week's video, there will be a clear depiction of a cool tongue here on the equator, suggesting the development of La Nina. The CDAS Nino 1.2 index, this is, this is uncorrected data, but you can see it shows temperatures steadily falling. This is the area right up there along Ecuador and the Galapagos Islands. Today, 157 thousandths of a degree below normal. That's not a big deal. You saw on the charts, though, that it is generally warmer over in that area, but the trend definitely downward. The Nino 3.4 index, so 2 weeks ago, it started making a dive. All last week, it continued. This week, all week, it's been down. Where are we at? 631 thousandths of a degree below normal. So the official, what's neutral is half a degree below to half a degree above. So now just in the past, I'll call it week, not even a week probably, we're starting to dip into La Nina territory. A week is not a trend at all. It is not the end of the world, but all the other data suggests this trend will probably continue for a while. The official sea surface temperature trend for the Nino 3.4 region right here, the last week was July 16th, so this is sort of looking back in time, but even then it was starting to drop 0.2 of a degree. That's, until it's down minus 0.5 of a degree or 0.6, you're still in neutral territory. But even, you see with -2 there, +2 there, but this is probably the beginning of the downward trend. The Southern Oscillation Index, our final bit of data here. The difference in pressure between Darwin, Australia, right there, and Tahiti in the Pacific Ocean, Darwin over the Indian Ocean. When pressure is lower in Tahiti, that would be like the development of El Nino, or at least the active phase of the MJO over the Pacific. The daily value plus 15.76. Looking back in time, well, it's hard to tell from looking at a month's worth of data, but it seems like the contribution or the trend is heading up. Look at the 30-day average, today's value plus 4.98. Where were we a month ago? We were down near zero. We're heading up. Now, this is heavily influenced by the MJO, but this sort of looks like at least the inactive phase of the MJO may be setting up. This is about, to get this is 15 days old, basically, worth of data. The 90-day average, plus 2.95. Where were we a month ago? 2.68. Yeah, about 3 months from now, or 2 months from now, you'll see this likely heading up as well. Let's go look at a chart. Here's the data graphed out, 30-day average, neutral. The Bureau of Meteorology in Australia says +7 to -7. I say +5 to -5 makes really no difference. You see our little spike here. This was as of July 25th, heading down a little bit, but there was our Modoki La Nina from last winter. It seems like we're probably going to be heading up somewhere in that territory again. Another piece of data, outgoing long wave radiation anomalies. Again, this is the oranges and reds are clear skies, no clouds. The blues would be cloudy skies. If the active phase of the MJO or El Nino were setting up, Here's the date line right here. You would have the blues at 180, but you see where they are. They're at the entrance to the far west Pacific, and I would have taken that as a win if we could hold there the whole way through the winter. But now, oh, and here was our La Nina from last winter, starting somewhere in like September. You see cloud-free skies that would likely be high pressure building and peaking in February and March over the date line. And right down here at the very bottom, you're seeing just the beginning of hints of, again, a sort of a building cloud-free sky pattern here in the West Pacific, where I had been hoping that we would see building clouds. It looks like that is getting cut off. I'm sorry, this is Nino 3.4 sea surface temperature anomaly forecast from the CFS model. It has been trending negative the past 2 weeks, but even much more so just in the past day or two. Here's today. This is mid-July, actually. The forecast now has temperatures. At one point, they were only down like, it was basically supposed to be neutral the whole way through winter. Then it was down to -4. Then it was down to -5. Today, minus 0.8 of a degree. That would be La Nina. Very weak La Nina. Again, La Nina starts at half a degree to -1 degree. That'd be weak El Nino. Moderate El Nino was 1 to 1.5 degrees, and between 1.5 and 2 is strong La Nina. This is showing a weak La Nina. Now, this is the raw data. PDF corrected probably takes into account some biases in the model. It says temperatures down to 0.75. Now, let's be clear. It's not 0.75 all winter long. It is basically for maybe a month or half a month, and it doesn't even fall into La Nina territory until October, okay? But then it basically holds from October to January, so that's a 3-month period. So putting things in perspective, this is probably another version of a Modoki La Nina setting up. The good news is, right now, we have 2 swells bound mainly for Hawaii, a third one developing, probably favoring the U.S. West Coast a little bit better. If one believes the model, a very solid storm is forecast pushing under New Zealand, or actually west of New Zealand, setting up potential long-period swell reaching into California. That swell probably will be shadowed for the most part relative to Hawaii. Fiji in that area, also in the target for significant swell activity. After that, though, based on what we're seeing on the models, it looks like easterly anomalies are taking over. Things will settle down, and that might be, I don't want to say the end of summer, but it very well could be. We'll have to see on that. And long term now, it looks like we're falling back into some version of a modest, well, really a weak Modoki La Nina kind of hole as we get into fall and winter. That said, there is momentum in the atmosphere. I was worried earlier about there literally being no momentum in the atmosphere and worried that come this fall, we would have nothing really going on because the atmosphere is so weak. It appears that the atmosphere has woken up, not in the direction that we would like it to be, but if it's moving and has momentum, that tends to do a lot better than just doing nothing. So we'll have to wait and see on that. So the bad news for this week is, yeah, it looks like some flavor of La Nina is definitely getting legs, and it doesn't seem like it's just going to disappear anytime soon, and this is just going to be a 2-week blip. That pocket of cold water in the Nino 3.4 region is not going to be denied. We'll just have to see how this all plays out. But for right now, not so much good news, at least for the immediate future. We'll just have to see. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. And if nothing else, you can go, yeah, I told you so, because I know some people were saying, yeah, La Nina's coming. Well, guess what? You were right, and I'd be happy to admit I was wrong. And then finally, if you'd like to make a small contribution to support the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We'll do it again next week, same time, same channel. Hope for the best. We'll see you then.